Hello and welcome to the Math Bender. I'm Adnan Zedi, and in this new section we'll talk about geometrical properties of circles. So let's start. Before starting off with the main topic, I need to ensure that we have a basic understanding what circular dynamics are. So let's say this is a circle of any radius, and this line starting from one point passing through the center and ending at the other point, this green line is called the diameter. Another line that passes through the center and ends at one end of the circumference or the outline of the circle is radius. And as you can see that we can establish by just looking at it that the radius 2 times the radius is equals to the diameter. Now, any line that passes through any point or starts from one point, ends at the other, but does not pass through the center is called a chord. Now, let's see more of it. If I draw another circle here, and from the center I break it, so as you can see that this section here is a small segment of a circle or a small slice of a circle that is using AB arc. Now the arc AB, I'll highlight that, the yellow one, the arc AB, I can write this as this one as arc AB. But the question is that then what do we call this arc? It is also using the same AB. So this is also using the same points AB. So in order to differentiate them, I can say that this is also arc AB, but since it's big, so we call this a major arc. And the smaller one can be written as minor arc AB. This angle here is facing this arc AB, and the other angle 360 minus that angle is facing this arc, the major arc, so called major angle and minor angle as well. Depending whichever arc they are facing, we name them accordingly. So from now on I will be using these terminologies in order to explain the theorems. Now let's see what we have here. If I draw a circle and this is the center line, with any radius that you draw, and you draw the line, the diameter, and using that diameter if you draw angles at the circumference. Now remember, the angle using the diameter at the circumference facing the diameter is always 90 degrees. You can observe that. You can make multiple angles like this anywhere using the diameter. So this is also 90 degrees. Now let's see, this is theorem number 1, and we can say that angle facing the diameter at circumference is 90 degrees. Now let's see some of the examples here. Now as you can see here, to find out B, this is an isosceles triangle, as clearly you can see this line is equals to this line, and so this angle is equals to this, so I can name that angle as well as B. But as you can see that this line is the diameter, and the angle using that diameter at circumference here is 90 degrees. So I can say that 90 plus B is equals to 180, sum of all the angles in a triangle. So I can say 2B is equals to 180 minus 90, and B turns out to be 45 degrees. So let's look at this one. As you can see that the first step to identify here is the diameter if it is connected, and as you could see it is passing through the center O, and the angle that is opposite is going to be this one, 90 degree. So same, I can say that 90 plus 4C plus C, all the three angles, is equals to 180, and 5C is equals to 180 minus 90, and C is equals to 90 over 5. So 5 times 1, so 18. The value of C is 18. You can find rest of the angles. Now let's look at another theorem here. Now this is the center, and this here at these 2 points, let's call these 2 points A, B, and center O. Now as you can see that A and B, these 2 points are, this is the minor arc, and the angle, this angle is facing the minor arc. Now if I use the same 2 points and make another now using the same 2 points, making another angle at the circumference. Now remember that the angle facing the same arc using the same 2 points, one at the center and one at the circumference, has a ratio of, if this is going to be x, then this is going to be 2x. You can draw all of them by using your geometrical set, and you can check for yourself. So we can write this as the angle facing an arc. When I say facing, I mean this face is facing this arc AB at the center, and this is facing the same at the circumference. At center is twice the angle facing the same arc at circumference. Let's look at these type of questions. Now, if you see the first one, the first step is to highlight the arc. This is the arc. And as you can see that if I mark these 2 points A and this as point B, and I can see that this angle here is facing at the center AB, and the same points are stretched, or the same arc, this angle is facing at the circumference. So the ratio of these two is half. So this is going to be 80 degrees. So this is going to be 80 degrees. And now to find out F, I can say that this line is radius, because from center to the other end of the circle is radius, and this as well. So which makes it an isosceles triangle. So if it is an isosceles triangle, so which means two angles are going to be same. So this is as well going to be F. So 80 plus F plus F, positive sign and F pretty much looks like the same, is equals to 180 degrees. And 2F is equals to 180 minus 80, and F is going to be 100 over 2, which makes F to be 50 degrees. Now let's look at this one. The first step, highlight the arc. So this is the arc that I'm talking about. At the center, it's making an angle 98. So these are the 2 points, point A and point B. And at the circumference is half of it. So I can say that this angle is going to be half of 98, or 49 degrees, by using theorem number 2 we just talked about. Now, in order to find H, let's take another perspective. If I draw a line here, now this line, I'm highlighting this line with a different color. So this line here and this line here, as you can see that this is radius, this as well is radius. So since if radius are same, so this is 21, hence this small one is going to be 21 as well. And since the whole big angle was 49, so if I subtract 21 from 49, I'll get this much as 28. And if you see that this line is also the radius, so this means that this triangle is also an isosceles triangle. So if this angle is 28, so hence this angle is going to be 28 as well. So H is equals to 28 degrees. Now let's look at this example here. If I highlight this one, so I need to find C and D. So C is going to be, as you could see, that it's a whole complete rotation. So angle C is going to be 360 degrees minus 100, which makes it 260. So this is 260 degrees. Now the arc that this angle C is facing at the center is this one. It's not a minor, it's a major arc. Let's call these 2 points point A and this point B, and I can say major arc AB as C is facing this green arc at the center, and D is facing the same arc at the circumference. You can check these 2 points. So D is going to be half of angle C. So 260 is going to be divided by 2. So angle D is going to be 260 over 2, which is going to be 130. So 130 degrees. Now let's look at another example here. If I highlight this arc, as you can see that this is the arc, and this point here I call this A, I call this B, and it is making, this arc is facing angle 54 at the center, and angle A at the circumference, same arc, you can check this. So angle A is going to be 54 over 2, 27 degrees. Now, looking at these questions, we need to get back to the theorem and look at the extension of it. So if I draw using these two same points, I draw a random another angle here at the circumference. Now this will be x as well. And wherever you draw them, you will observe that all of them are same. So I can write this down as another theorem. Angle facing the same arc at circumference are all same. And let's look at the example here. So this is 35. Highlight the arc, this one, and these two are the points. Writing that down as A, this point here A, and this point here is B. Now, as you can see that 35 is the angle at the circumference facing the arc, minor arc AB. The same is angle A facing the same arc, extended by the same arc AB at circumference. So A is going to be 35 . So as we can see that both of the angles, angle A and angle 35, are sharing the same arc at the circumference. So according to the new theorem, so they're both sharing the same arc at circumference, so A is going to be 35. That's it. You don't have to do any calculation to perform that. Now, getting back to now the question. So this is 35, this angle here is 35, and I can see that this line passing through the center ending at the other end, B, is a diameter, and hence this angle is going to be 90 degrees. So I can say 90 plus 35 plus B is 180 degrees, because sum of all the angles in a triangle is equals to 180, and B is going to be 180 minus 90 minus 35. So B is going to be 55 degrees. Now let's look at this one. So as you can see, angle G and angle H are actually facing this arc, but angle 175 is facing the other arc, this direction. As you can see, it's facing this arc, so we don't need that. We need this angle at the center, and this can be 360 minus 175, which gives you 185. So this angle here is 185 at the center, and this is facing this arc, and same goes at the, so according to our theorem number 2, so angle G is going to be 185 over 2. So this is going to be 92.5. And angle H, according to the new theorem number 3, so they both are sharing the same arc at circumference. Angle H is going to be also 92.5. Last question of the day. Now as you can see that angle A, I'll make these two arcs. So this is in one arc, and I'll write this point as point A and this point as point B. So angle 210 is facing the yellow arc, and angle A at the circumference is facing the same arc using these 2 points AB. So angle A is going to be 210 over 2, which makes it 105. So angle A is 105. Angle B is, since it's a whole complete rotation at center, so angle B is going to be 360 minus 210, which gives you 150. So this is 150. Now highlight another arc, and as you could see, angle AB has a major arc, and angle B is facing that arc at the center, which is 150 degrees. And angle C is facing the same arc using these two same points. The arc is up to here only, this much. And as you can see that angle B is facing this arc, so let's call it C, BC, arc BC at the center, and angle C is also facing the same arc at the circumference. So angle C is going to be 150 over 2, which is going to be 75 degrees. So that's it for today. I'll come up with my next session on more theorems. Until then, take care. Bye.